In today's video, we are going to learn about Booleans and relational operators, as well as comparing strings and checking for equality with strings. First, let's talk about some different relational operators. We discussed these the other day, and within math, even though we have a greater than or equal to or a less than or equal to operator, there's no symbol for those, so we use the greater than and then equal sign, and the less than and then equal sign. And then remember that the not equals is the exclamation point, and that exclamation point is essentially the negation, which means not. And we'll see that being used in other places as well. When we are using our equal sign versus our equals, remember that a single equals is going to assign. So in this scenario, I am assigning the value of 5 to the variable a. And we always assign from right to left. In the second scenario, I am first checking to see if a is equal to 5, and then whether or not this is a true or false condition, that answer will be replaced here, and then if that answer were true, the code is executed, else it is not. Now this next point says that relational operators have lower precedence than arithmetic operators. So what does that mean? That means that we're going to go ahead and do anything on the left, and then we will do anything on the right. And then after we've done that, we will go ahead and we will evaluate the comparison or the relational operator to see how the two different values compare. All right. One of the laws that we are going to learn about is De Morgan's law. And what De Morgan's law talks about is how to negate an and or an or statement. So if we take a look at De Morgan's law, we can see that if you not an and, it turns into an or. And if you not an or, it turns into an and. And the way that I like to think about it is it's almost as if the not is distributed and the and the or signs switch. Now, I find it easiest to explain this through a math example. So if I were to consider this scenario, x is greater than 3 and x is less than or equal to 5. If I were to graph that on a number line, I would have the 3, I would have the 5, I would have a parenthesis here, I would have a bracket here, and it would be this whole scenario in the middle. Now, if I wanted to negate that, that's going to get everything but what I have colored in red. So since this was a parenthesis, I would have a bracket here, and I'd have the arrow pointing this direction. Since this was a bracket, I would have a parenthesis here, and this would be pointed in this direction. And the way that I would write that is I would say that x is less than or equal to 3, or when we're going opposite ways, x is greater than 5. All right, so now if I were to take this and write it with mathematical symbols using De Morgan's law, and I knotted this and changed it to an or, and knotted this, that would go ahead and give me x is not greater than 3, which means it must be less than or equal to, or x is not less than or equal to 5, which means it is greater than 5. Okay, so kind of a little bit of a mathy lesson there, but essentially just remember that the not sign distributes, and then the and switches to an or, and the or switches to an and. Now, when we use our Boolean values, it's very common practice within our loops. Instead of saying, for example, instead of saying if done equals true, that's kind of silly because a Boolean by nature evaluates to true or false. We can just say if done. Or in this case, we can say if not done. So as long as something is not done, as long as the not of false equals true, continue doing this. And this will be a technique that we will see a lot when we are code tracing. So even if you don't feel comfortable writing the code that way, we want to get good at tracing the code. When we are using our Boolean values, we always want to name our variables in ways that are kind of answered as short-worded questions. For example, if I have a Boolean called married, then if it's true, I know the person is married, and if it's false, I know that they're not. And so then in my code, I can either write if married equals true, or I can just say if married. And essentially, if the married Boolean is true, then this code is executed. If the married Boolean is false, then it goes on to the next one. And I can keep on moving on down the line. Now, when I want to compare strings are different because they are objects. Now, a Boolean and an int, those are all primitive data types, and that's why we can use the less than, the greater than, the equal to symbols there. We can use those for primitives, not for objects. So, when I want to compare strings, this is not how I do it. If I were to go ahead and run this code through Java, it would not give me what I expected. And when we read it at first look, we see two identical string values. So we think that if we use equals, it's going to check to see if those are the same strings. However, that is not the case. Instead, it checks to see where these strings are stored in memory. And since they're different variables, they were declared differently, they'll be stored in different places, so their addresses will not be equal, and that will be false. Now, when we are comparing strings, we are going to use this ASCII code table. Now, this is not something that you need to memorize at all. I just wanted to put it on here for reference. And if you look at this column over here where we see the character, we're going to see our numbers, then we'll see our capital letters, and then we'll see our lowercase letters. So when the computer is comparing characters, it is going to compare the ASCII code, which is the decimal column. So the ASCII code is this column right here. It's going to compare those numbers. And so if a value has a smaller ASCII code, according to the computer, it comes sooner or comes first. And this is important to recognize because if you notice, we have all of our capital letters and then we have all our lowercase letters. So according to the computer, the letter capital M, for example, comes before lowercase a. And in most cases, if you were to alphabetize, you wouldn't think of an M coming before an A. So we need to remember that about the string methods. All right, so let's talk about these string methods. First of all, we can't use the equals, and that is a big no-no, so please don't do that. You cannot do that. Like I said, it does not compare the contents. All that it does is check the address. So instead, we need to use a special method that's built into the class. And the method that we are going to use is, there are three different methods that we expect you to be proficient in: equals ignore case, and compareTo. Okay, so here's how these three methods work. First of all, equals works the way that you would expect. Instead of using the equals symbol, which does not work for objects, the dot equals method essentially checks to see if the contents of the first string and the second string are equal. Now, in some cases, you might have somebody, for example, write the word Dana and somebody else write Dana in lowercase. And if you were asking them who their teacher was, clearly I'm both of these people. So in that case, we'd want to ignore capitalization. So then we could use equals ignore case. And in that case, the computer would treat capital D and lowercase d as the same. Now, finally, we have the compareTo method. And compareTo method is one of those methods that people often forget how it works. This is a biggie. We need to know how this method works. We need to remember the rules. So first of all, it's going to do an alphabetical comparison, and it's going to compare according to that ASCII table that we looked at a few tables before. And so what this method does is it returns an int, and it will either return a negative number if the first entry comes before the parameter. It returns 0 if the strings are exactly identical, and it returns a positive number if the first string comes after the parameter. And this is a more flexible method than equals because equals only tells us if they are the same or different, whereas compareTo allows us to sort the values or compare one to the other. And in some cases, we will first convert the strings to lowercase or uppercase, and then we will run the compareTo method on them. And the reason why it returns a negative or a positive is because the computer compares character by character to see if they're equal. And then as soon as they're not equal, it subtracts their ASCII values. And the number that's returned is actually the difference as to how far apart the first non-identical characters are in the string. All right, so if we were to take a look at this next example where we have our compareTo method, and we have these two different strings, we have Bloomington and we have Urbana. Remember that in our ASCII chart, first we see numbers, then we see capitals, then we see lowercase. And so because of that, the computer is going to think that Urbana comes before Bloomington. And alphabetically, we would consider Bloomington coming first. And so if I were to go ahead and run this code, if the first one comes before the second one, let's look back at our rules. So if the first one, the calling string, comes before the parameter string, it returns a negative. Okay, so let's see if that would be the case. So the first one is Bloomington. Does that come before Urbana? Well, it doesn't according to this rule, okay? Are they equal? No, they're not equal. And so it would actually default to this scenario right here, which is the other one, where the calling string comes after the original string. And as we stated, we wouldn't think of it normally to be that way, but that's how it would run. Okay, so to summarize, the equals operator tests whether two object references are identical, meaning if they have the same address in memory. The dot equals method checks whether two objects have the same content. Now for strings, that's checking to see if the two strings are equal. Now I put a note here that says as we get more into the course, you will write your own equals method as needed. And that's because as we create our own objects, like how we created our own emoji or as we create our own bank account, what is determined of whether or not they are equal will be different based on the object code you write. So that's why you as a programmer will create your own equals method. And this is a biggie right here. Strings are objects, so you cannot use equals or less than to compare them. Okay, so in this scenario, we are taking a look at a rectangle object. Now, even though we don't know the code for the rectangle, we can tell that rectangle is the class because of the capital letter. This right here shows a call to the constructor. We have the keyword new, and that keyword new is going to instantiate and create a new rectangle. Box 1 is the variable name for that rectangle. So essentially what I have is I have a reference variable box 1, which is pointing to a rectangle object. And then in this next line of code, I have another rectangle called box 2. And this one is equal to box 1. What does that mean? That does not mean it made another object. It means that this address points to the same location. The way that we know we've only created one rectangle is because I've only called the word new one time. Now down here, I make another new object. So now I have box 3, which is pointing to another rectangle object. So right now I have created 2 objects and I have created 3 references. And even though the values are exactly the same for both of those rectangles, we would not be able to say that box 1 and box 3 are equal because they actually point to different areas in memory. We could say that box 1 and box 2 are equal because they point to the same address. So this is a little bit tricky here. The next slide shows a visual for this. So here we can see the 2 different reference variables to the same object, and this is a different variable to a different object. And this whole concept of the reference variables in memory is something we're really going to dive into this year with object-oriented programming. And last but not least are different assignment operators. You may have seen these in other languages. This is essentially just a shortcut. So the plus plus and the minus minus allows us to add 1 or subtract 1. And this right here is the x minus minus. It looks like it's 1, but it's really a minus minus. And then we can also do the plus equals and the minus equals. And the way that that works, it essentially says, I want to add y to x and save it back in x. So this is the same as saying x equals x plus y. It's just an abbreviated form of doing the arithmetic. All right, that's it for today.